Hi everyone, in this video we will talk about the famous Carbonaceous Chondrites meteorite. Disclaimer: this video is for educational purposes only. Any details and information are based on my research from reliable website source. So without further ado, let's start. Carbonaceous Chondrite. Carbonaceous chondrites, which are meteorites that presumably represent the primordial composition of the Earth as a whole, are enriched in iron relative to manganese compared to the Earth's crust and mantle. Carbonaceous chondrites or sea chondrites are a class of chondritic meteorites comprising at least 8 known groups and many ungrouped meteorites. They include some of the most primitive known meteorites. The sea chondrites represent only a small proportion, 4.6%, of meteorite falls. On this video we have 10 famous Carbonaceous Chondrites meteorite, and number 1 on our list is Allende. Allende is one of the most well-known Carbonaceous chondrites. It fell in Chihuahua, Mexico, in 1969 and is considered one of the largest meteorite falls in recorded history. Allende contains abundant small, refractory inclusions that provide insight into the early solar system. The Allende meteorite, which is classified as a Carbonaceous chondrite, consists of large, irregularly shaped white inclusions and rounded chondrules in a dark matrix. The inclusions are composed of minerals believed to have condensed at high temperatures from a gas having the composition of the Sun, and their time of formation is older than that of any other known solar system material. The inclusions in Allende and other Carbonaceous chondrites are thought to be the earliest formed solids in the solar nebula. Number 2. Murchison. The Murchison meteorite fell in Victoria, Australia. Murchison meteorite is one of 16 meteorites known from Victoria, and is rare in that it was actually observed falling, rather than just being found on the ground, so it came to scientists fresh. It exploded in the atmosphere over Murchison, Victoria, about 160 kilometers north of Melbourne, on September 28, 1969. It is known for containing a wide range of organic compounds, including amino acids, which are building blocks of life. Murchison has provided valuable information about the early stages of our solar system. The largest piece found weighed nearly 7 kilograms, though many more were just a few grams each. In total, around 100 kilograms was collected and over 80 kilograms of that made it into science collections. While a lot of the material went overseas, mostly to the Field Museum in Chicago who have nearly 52 kilograms and the Smithsonian in Washington, D.C. who have nearly 20 kilograms, some remained in Australia. Over 7 kilograms stayed at the University of Melbourne, and much of this was later donated to Museums Victoria. We have about 3.5 kilograms, and whilst only the largest pieces are on display, we also have lots of smaller pieces. Number 3. Orgyll. The Orgyll meteorite fell in southwestern France in 1864. It is one of the oldest known Carbonaceous chondrites, dating back over 4.5 billion years. Orgyll contains a high abundance of organic matter and has contributed significantly to our understanding of prebiotic chemistry. It is classified as a Carbonaceous chondrite, a type that comprises the most primitive meteorites, ones having a chemical composition much like that of the Sun and thus of the solid material that formed at the birth of the solar system. About 20 fragments of the Orgyll meteorite were recovered. Their analysis soon after the fall revealed the presence of hydrogen, carbon, and oxygen, and that its substance resembled peat and coal. Subsequent examination showed that hydrocarbons were present. The meteorite was once at the center of a dispute about extraterrestrial life, prompted by similarities between its organic matter and hydrocarbons of biological origin on Earth. Number 4. Taggish Lake. The Taggish Lake meteorite is an extremely rare type of Carbonaceous chondrite that fell in British Columbia, Canada, in 2000. It is characterized by small, fragile, and primitive particles that have preserved the chemical and isotopic composition of the early solar system. The Taggish Lake meteorite is classified as a Carbonaceous chondrite and is a fragment of a D-type asteroid. Asteroids are small celestial bodies found mainly in an area between the orbits of Mars and Jupiter known as the asteroid belt. D-type asteroids have a surface which is mostly composed of silicates with carbon contents. They have a very low albedo, meaning that they only reflect a small amount of incoming radiation. D-type asteroids are comparatively rare and are located in the outer regions of the asteroid belt or in orbits similar to that of Jupiter. Number 5. Ibuna. Ibuna fell in Tanzania in 1938 and is known for its high carbon content. It contains organic compounds, including amino acids, sugars, and purines, which support the idea that life's building blocks were present in the early solar system. Ibuna is the type specimen for the C chondrite group of meteorites, which are extremely rare. Only 9 are known to exist on Earth. C meteorites are the most chemically primitive meteorites known, and are believed to have formed in the outer reaches of the solar nebula, where they were never heated to more than 50 degrees Celsius (122 degrees Fahrenheit). They are distinguished by the complete absence of chondrules and refractory inclusions, and high degree of hydration. Current studies link the C meteorites to C-type asteroid 162,173 Ryugu, and samples returned by the JAXA Hayabusa 2 spacecraft point to origins at the edge of the solar system. Number 6. Sutters Mill. The Sutters Mill meteorite is a carbonaceous chondrite which entered the Earth's atmosphere and broke up at about 7:51 Pacific Time on April 22, 2012, with fragments landing in the United States. 6-7. The name comes from Sutters Mill, a California gold rush site, near which some pieces were recovered. 3-8. Meteor astronomer Peter Jenniskens assigned Sutters Mill SM numbers to each meteorite, with the documented find location preserving information about where a given meteorite was located in the impacting meteoroid. As of May 2014, 79 fragments had been publicly documented with a find location. The largest SM53 weighs 205 grams, 7.2 ounces, 4-9, and the second largest SM50 weighs 42 grams, 1.5 ounces. Number 7. Winchcomb. The Winchcomb meteorite is a carbonaceous chondrite meteorite that was observed entering the Earth's atmosphere as a fluorescent green fireball over Gloucestershire, England, at 21:54 hours on the 28th of February 2021. Due to a public appeal, fragments were quickly recovered from the village of Winchcomb, enabling it to be collected for analysis before becoming degraded. Number 8. Renazo. In January 1824 a meteorite fell in Renazo. During the descent, the meteorite broke into 3 main pieces plus and many small fragments. The main pieces were collected on an area about 1.5 kilometers in diameter, while the smaller ones were spread over surrounding fields. The impact point of the meteorite was not well recorded in scientific documents of the time. After extensive research using old documents and site inspection, Thomas Mozzie was able to reconstruct the event and find the main impact point of the Renazo fault. Renazo meteorite notable for its abundant presillar grains. These grains are believed to have formed in stars before our solar system and provide insights into stellar evolution and nucleosynthesis. Number 9. Coldbakavel. Coldbakavel is a carbonaceous chondrite that fell in South Africa on October 13, 1838. It is known for its relatively high water content, as well as organic compounds and amino acids. The Coldbakavel meteorite is estimated to be about 4.5 billion years old, which is roughly as old the solar system. However, it contains something older still, microscopic diamonds. When heated, these diamonds release the inert gas xenon. The mixture of xenon isotopes found in the diamonds has not been found anywhere on Earth. Number 10. Olay. Olay fell in France on March 15, 1806 and is one of the oldest carbonaceous chondrites ever discovered. It contains a wide range of organic compounds and has provided valuable information about the early solar system's chemistry and the origins of life. The Olay meteorite is a meteorite, weighing about 6 kilograms, of the type known as a carbonaceous chondrite. It became the first object from space in which organic chemicals were unequivocally identified. This conclusion came following an examination of the Olay meteorite, years later, by Jöns Jacob Berzelius. In his published analysis of 1834, Berzelius claimed that, in addition to clay minerals, the meteorite contained complex carbon compounds which he had distilled from a specimen extracted with water. His announcement ushered in the study of organic substances that have originated beyond the Earth. These 10 famous carbonaceous chondrites have greatly contributed to our understanding of the early system, organic chemistry, and the potential for life beyond Earth. The discovery and study of these 10 famous carbonaceous chondrite meteorites have not only provided insights into the origins of our solar system but also shed light on the potential for extraterrestrial life and the formation of organic compounds essential for life as we know it. And those are the famous Carbonaceous Chondrites meteorite. Thank you for watching. Please like, share and subscribe to my YouTube channel for more videos.